Good day, everyone. We're from BSCS-3A Group 3, presenting basic concept of graph and tree search. So, what is graph and tree search? Tree and graph comes under the category of nonlinear data structure, where tree offers a very useful way of presenting a relationship between the nodes in a hierarchical structure, and graph follows a network model. So, to further discuss the tree search, let me call in Mr. Joseph Brendon Loremia.
Okay, so next is tree search. A tree is a finite collection of data items usually termed as nodes. It is used to show a hierarchical structure between the various data elements and organizes the data into branches. So ang best example na to is ang katong kuan binary tree search. So nako example dere for binary tree search. So ang iyang root which is the so nako example dere for binary tree search. Example to sa ibabaw is ang computer hardware. So sa computer hardware natay hard drives, memory, SSD. So sa memory nasa tay tulo ka types, ang desktop memory, ang laptop memory ug ang server memory. Mao nay example of binary tree search. So ang bubble katong nay salingin represents a node nya. The arrows pointing from the bubble to another bubble are called edges. A node ito siya sa kuan sa kada bubble nya. The arrow pointing from the one bubble to another bubble ang is ang edges. Ang topmost node ang katong nasa babaw which is the computer hardware with no edges leading to it's called the root. Ang root ang katong tas ubos. Ang hard drive memory ang hard drive ang memory ug ang SSD nya ang desktop memory, ang laptop memory dayon ang server memory. Mao toy yang mga root. Nya one or more nodes that immediately follow from a node is called a child. A child din tawag sa kuan day. Another important term is depth of a node, defined as the length of the path from the root node to that node. So, mo siya. Next is properties of a tree. There is designated node at the top of the tree known as the root of the tree. The remaining data items are divided into disjoint subsets referred to as subtree. The tree is expanded in height towards the bottom. And a tree must be connected with, which means there must be a path from one root to all other nodes. And it does not contain any loops. And a tree has n minus 1 edges or n negative 1 edges. Okay, maro to ako. Salamat.
Today, I am here to continue the report. So, graph. A graph is also a mathematical nonlinear data structure which can represent various kinds of physical structure. It consists of a group of vertices or nodes, a set of edges that connect the two vertices. Vertices on a graph is represented as a point or circles, and edges are shown as arcs or line segment. So, searching graphs provide an appropriate level of abstraction within which to the study simple problem solving independent of a particular domain. A directed graph consists of a set of nodes and set of directed arcs between the nodes. So the idea is to find a path along this arcs from a start node to a goal node. So these are the properties of graph. So a vertex of graph can be connected to any number of other vertices using edges. And edge ka mo direct sa or mo direkta, and edge can be weighted. So this report will continue to Brendon.
Difference between tree search and graph. Here are some key differences in tree search and graph. In a tree, there exists only one path between any two vertices, whereas a graph can have unidirectional and bidirectional paths between the nodes. A tree cannot have loops and self-loops, while graph can have loops and self-loops. In the tree, there is exactly one root node, and every child can have only one parent. As against, in a graph, there is no concept of the root node. A tree has a hierarchical structure, whereas graph has a network model. In conclusion, graph and tree are the nonlinear data structure which is used to solve various complex problems. A graph is a group of vertices and edges where an edge connects a pair of vertices, whereas a tree is considered as a minimally connected graph which must be connected and free from loops. That's all. Thank you.